So the question number one, which is very surprising, the question number one for the trouble for many people. It states that he holds the suitcase stationary off the ground. If the object stationary, what is the net force? Of course, zero. If object station, it can be stationary only if the net force is zero. Then question two. 50-gram toy car performs a loop in the apparatus shown. The radius of the car, you have a radius. When the car reaches point B, it is traveling at the given speed, 1.4 meters per second. So the car is underneath. Which one of the following best describes the magnitude and direction of the force exerted by the truck on the car when the car is at point B at the top? So we have at that point forces acting. We have N and we have mg. And they adds up, because it's circular motion, should adds up N plus mg equals mv squared on R. So normal reaction, if you find normal reaction, because that's what the car exerts by the truck on the car is normal reaction, will be N equal mv squared on R minus mg. If you substitute numbers, you have 0.25 times 1.4 squared over radius 0.2 minus 0.25 times 9.81, and we get negative 0.0025. So out of the given answers, it's only 0 newtons. Question 3. Changing speed limit from 50 kilometers per hour to 30 kilometers per hour. How it will affect, how it will change the braking distance for the same car and the same road conditions. You don't have, because we will be using ratio, so we don't need in this case to convert kilometers per hour into meters per second, because we'll be using ratio. And in this case, we have S equal U squared divided by 2A, because we have V squared equal U squared plus 2AS from SWAT equations. And we have, it stops, final velocity 0, so we get S equal U squared over 2A. So we have S1 equal 30 squared over 2A. We have S2 equal, this is S2, which one was first, 50, let's say this is S2, S1 is 50 squared over 2A. Formally saying we should change this into the kilometers from kilometers per hour to meters per second, but because we find in the ratio S2 over S1, it doesn't matter kilometers per hour or meters per second, so we will have that will be will be 30 squared over 50 squared. So correct answer is 0.35. So ratio is 0.35. Make sense? You just write there stopping distance for one initial velocity, for another initial velocity, and just divide one by another. Make sense? Question 4. And here, from my point of view, to be honest, it's not that much physics question, it's more English question. What is more correctly to say and more correct will be say B, that to absorb some of the initial collision kinetic energy, because we don't say absorbs momentum. Momentum we say transfer. Speed we don't say absorb speed, and we don't say it can be said, I think, absorb forces, but English is not like my native language. I might be wrong, but so the best is absorb energy.
Is there ever a question like that on the exams?
It was a couple years ago. So that's from multiple choice what was done not good. Next question that was done not well, question 9. The first 4 questions were not done well. The next one, question 9. Question 9, light bulb rated at 15 watts carries RMS current of 1.5 amps. So we have power equal 15 watts, current, RMS current equal 1.5 amp. We need to find voltage peak to peak. First, let's find that, because how we find in power? We multiplying RMS. No, we find in power, it's current RMS times voltage RMS. So first we find in voltage RMS, 15 divided by 1.5 will be equal 10 volts. Now to find the peak voltage, we multiply by √2, and peak to peak, because what is peak to peak? If you have voltage change against the time, let's say something like this is peak voltage. Peak to peak is double amplitude. So voltage peak to peak will be 2√2 times 10. So correct answer is D, 28 volts. Next question, which was not done well. So pretty much most of other questions, no, question 14 was not done well as well. Everything else was done pretty well. Question 14. Synchrotron light is produced by electrons traveling at very high velocities. Electrons emit light when they travel at a constant speed in the curved path in the synchrotron. They emit light in the curved path because when charge is accelerated, it emits electromagnetic wave, which is light. And motion in the circular motion, even with a constant speed, is a motion with acceleration. So electron will emit light. So correct answer is A. Yes?
Can you please explain question 7?
Question 7, yes. Question 7. We have the solenoid with a current, and we have a wire with a current. This is the direction of the current in the wire. Question is, find the direction of the force on the wire. First, we need to find direction of the magnetic field created by the current in the solenoid. Using right-hand grip rule, and in the way how I showed you with the solenoids, when you use those fingers for the current, and this finger will give you magnetic field. So if current going like around like this, so in this case it's going like this. So magnetic field is this way. Magnetic field created by the solenoid is from right to the left. Now we have current in the magnetic field. we applied right-hand slack rule. We have 4 fingers magnetic field, thumb direction of the current, so force will be out of the page. Okay, that's all about, any other questions you want to hear about the multiple choice? No? Going to the short answer. Again, we'll go over only questions which were not done well. And the first question which was not done well, which was the trouble, is question 4C. Question 4C, but we probably will go over the whole question 4. Question 4A. 4A is example, which I believe if such question will be on the example, then it will be decided to accept two answers. Not definitely, but might be, because it says calculate the magnitude of the change in the gravitational potential energy of the mass as the bouncer is lowered. I see that because it says that they place a mass of 4 kilograms in the bouncer. So this question relates to 4 kilogram mass. But it's not the best wording, because you might, quite a few people consider the mass of the bouncer with mass, so I take 5 kilograms, not 4. So it should be taken 4 kilograms, and that's arguable because it's not very clear. But what they mean, and I'm sure that's 100% what they mean, that because it's saying mass, they put mass, and question is about changing the gravitational potential energy of the mass. That will be equal, obviously, mgh, so 4 times 9.81 times 0.05 equal 1.96 joules. Bringing your attention, I always use a 9.81. As at 9.81, it's not that hard to write when you will be. Remember, substitution, if question worth more than 1 mark, you must show your substitution, and that substitution worth marks. So you must show it, put 9.81. In the calculator, if you put even 9.8 and 9.81, there will be pretty much no difference in your answer, but better use 9.81. Yes?
Is it okay to just write G?
Huh?
Is it okay to just write G?
In the formula, yes.
But when
But-
you show, because I just wrote 4G times 0.05.
Yeah, I'm fine with that, personally. But yes, usually saying selling a substitution, you need to show it. So this one, quite a few people use 5 kilogram mass. Now, part B. Part B even more unclear. So I was accepting 2 solutions to part B. They say calculate the elastic strain potential energy of the stretched spring in the equilibrium position. But it's not clear was the bouncer lowered from unstretched position or from the position where spring was already stretched by the mass of the bouncer. Because bouncer has mass, it will stretch the spring. So as it was not clear, I was accepted both solutions. So one solution, if we consider that spring initially not stretched at all, that we hold in the bounce, so spring not stretched at all. Then, because at the equilibrium position we have mg equal kx. So from here k equal mg divided by x. And so k equal 981 newtons per meter. Or it could be that if it's lowered from the already stretched by the mass of the bouncer, that will change the x, not 0.05, but then we need to consider that, 0.05, that it was straight from the position where it was already so if it was K we have found, K can be this, or if you put 0.05, yes. If you put 0.0625, so depends what x we take in the
Which
account.
X is that?
Hmm?
What X is that?
This one, if it's from unstretched position. Because the bouncer itself will stretch it. So if you take then, this will give you different K, will give you K bigger. So I will be consider this one, this 0.05. That's probably what they mean. But question absolutely unclear what they mean by the equilibrium, how they worded question. So we'll consider this one, then we just, when we found K, it just E equal Kx squared on 2. And using 0.05, we'll get 1.2 joules. And what was the question C that was people struggling the most? If you can see that change in gravitational potential energy is greater than change in the elastic potential energy. Why is that? Why is it? Some people were writing that conservation of energy, it should be equal, but numbers showing that it's not equal, and we did such question. Why they're not equal? Why the change in GPE greater than an elastic potential energy? Yes?
Wait, now.
No, okay. Yes.
On this side, the emitter is heat.
If you drop the mass instead of lowering it, it has kinetic energy as well. So when the person lowers it, the thing loses its kinetic energy, so it doesn't go.
You started in the right thing, in the right direction, but not the right answer. When I, let's say, hold this, and I lower it, am I applying force?
Yeah.
Yes. Does this apply force to my hand? Yes. So the system does work on my hand. So it's losing energy due to the work done on the hand. So if you lower something, not drop, you lower something, the energy at the top will not be equal energy at the equilibrium position if you gently lower it. Because system does work on your hand by law. It's applied force to your hand, and your hand moving down, there is a displacement. Make sense? No, system does work on your hand, right? If something does work, it's losing energy. Okay. Next question, where there was a trouble. Question 6b. Question 6b. Question 6b. More detailed about the question 1 and with the different calculations. I've uploaded my solutions to website of this exam. Detailed solution you can watch. So question 6. What is question? Question B asking, determine the energy of proton in electron volt as its exit electric field. So electric field, it's easy, part A, almost everyone done correctly. Electric field equals voltage divided by the distance between the plate equal 10,000 divided by 0.2 equal 50,000 volts per meter. But part B, how we calculate the energy of the charge in the electric field? How we calculate energy of the charge in the electric field?
QB.
Charge times voltage. But what is energy in a 1 electron volt? What does it mean, 1 electron volt? What energy is that? What is 1 electron volt? It's an energy gained by electron when it's going through the potential difference of 1 volt. What charge proton has? Same as electron, just positive. So when proton will go through the voltage or potential difference of 1 volt, how much energy it will gain? One electron going through one volt, it gains energy 1 electron volt. If proton going through the potential difference of 1 volt, it will gain 1 electron volt. Proton has same charge as electron. So if proton going through the 10,000 volts, how much energy it will have? 10,000 electron volts. You don't need to calculate anything. It's one more question. Proton has same charge as electron. If it goes through the potential difference of 10,000 volts, its energy will be 10,000 electron volts. And there is a unit, if there is in the answer box, there is a unit, you must answer in that unit. So 10,000 electron volts. And speed of the proton, you just all gain energy, turn into the all electric potential energy, turn into the kinetic energy. So V equals square root of 2Q times voltage divided by mass, and will give you 1.37 times 10 in the power of 6 meters per second. And radius MV on QB, which gives you 0.53 meters. Now, part E, modification to modification to the value set for the experimental equipment that will allow to hit target in the new position. So radius has to decrease. To make radius smaller, how we can make radius smaller? Either we cannot change Q, we cannot change M. We have two quantities to play with. One, magnetic field. So what we need to do with magnetic field? We need to make it stronger, or we need increased speed. How we can increase speed?
Do we decrease speed?
Huh?
Do we decrease speed?
We need decrease speed to make radius smaller. How we can decrease speed? Make the wall accelerating voltage smaller. So that's two options. Next question, question 7b. Question 7b was almost complete disaster. So when we have DC motor, we have coil, can you borrow this for a second? So DC motor, we have coil, let's say magnetic field is that way. The magnetic field is that way. And initially current in the coil is going this way. So what is the direction of the force on this side? Magnetic field that way, current this way, so we have up on this down. What are the magnitude of this force? What the magnitude of the force of the magnetic field on the current? B, I, L, sine theta. When we rotate, when coil rotates, does B changes? Current changes? Length of the side changes? No. Does angle changes? No!
Angle between
And between the current and magnetic field that way, current this way. What the angle between them now? Current this way, magnetic field that way, 90 degrees. In this position, still magnetic field that way, current this way. What the angle between this line and this line? Still 90 degrees. Still 90 degrees. Angle does not change. So it will be, the only what changes direction of the current every half turn. So we have force against time. We will have constant force one direction. Then when the split ring switch direction of the current will be same force opposite direction. Then again, split ring change direction will be the same force. Angle does not change between the motor, between the magnetic field and the current. So that will be the answer. No.
It's better or worse. Mr. B, is it better or worse to do like the connecting lines or not to do it?
It does not matter at all. Both, if you do like this,
Does that have to be done?
or if you do dotted line. If you don't do line, just put those lines, perfectly fine. If you put dotted lines, perfectly fine. If you draw the continuous line, but just vertical, perfectly fine. No difference. Yes?
Why is it 3? Because it goes one direction and the opposite direction.
Because of the split, because split ring. Split ring, the current will change direction. So
It's one revolution.
yeah,
So it goes
not half revolution, whole revolution. It turns direction of the current every half turn. So for the whole turn it will.
So wouldn't it do it twice? Wouldn't it change?
It's just graph. It starts like this.
Yeah.
Flips.
So it's
Yes.
Just again.
Yes, it's changed twice.
Guys, I don't hear the question. Shh. Sorry.
What would the graph look like for a slip ring from a slip ring? Like if it was force versus.
If it will be slip rings instead of split ring, their force will be all the time in the same direction. Constant. It will be constant. Will be just straight line.
So we
That's a good thing.
Force will not change. That's why it will stop rotating, because we need to flip the force.
wait, I don't understand why you have 4 lines and not 2. Because if it changes every half turn.
What do you mean? Where is 4 lines?
Oh, you have 3. Yeah, why do you have 3?
It starts from the horizontal position
Yeah.
on the diagram. It starts from the horizontal position. At the vertical position, which part of the turn this is? Quarter. At quarter turn, current change, force change. Then, from this position, it makes half of the turn, and then current switched again.
So it goes a quarter and then.
Quarter, half, and another quarter. Yes.
He asked for slip rings, but I thought you can't have a force for slip rings because it's being turned by itself. Or is that not?
Slip rings, it's how we connect. You can connect slip rings,
But
and
it
you
doesn't-
can connect current, you can connect
It
battery.
doesn't turn by itself, the slip rings. right?
Doesn't turn by itself.
Yeah, so you have to turn it, so then you can't have.
No, no,
force.
if you turn,
Yeah.
there will be not talking for that will be generator, not motor. But if you have a motor, what the difference? In motor, we supply electrical energy and we get mechanical energy of rotation. In the generator, other way, we supply mechanical energy,
Yeah.
get electric. But if we connect same DC motor, we just change connection, slip rings, still connect battery, we don't rotate.
Yeah. So then
We
there is
don't
no-
rotate. We connect, but it will
Yeah.
start rotate. The problem is that it will rotate to vertical position and just
Yeah, okay.
oscillate around it. Okay, next question, 8B. Where was the trouble? 8B, we have generator starts rotating from rest and speed of rotation gradually increases. So sketch graph of the EMF against time. What happens when we're rotating the coil, but we rotate it faster, faster and faster? First, what happens with the amplitude? Because we have that EMF equal of minus n rate of change of the flux over time. If you rotate faster, faster and faster, what happens with the rate of change?
Increases.
Increases, so amplitude increases. What happens with the period? Decreases. So there we should have start small amplitude, big period, then amplitude increasing, period decreasing. So bracket asked to do 2 complete revolutions. So 1 to 3 peaks. So something like this. Probably this should be a little bit more than this. Not perfect drawing, but idea, you got an idea. Amplitude increasing, period decreasing. Make sense? That was 8B. Also 8D. Explain, this was shocking. You should know the role of the slip rings in the AC generator. What are the role of the slip rings? Maintain constant connection of the coil with the external circuit. For what? To take current from the loop without any changes.
Can you repeat that, please?
Role of the slip rings is maintain constant connection between the loop and external circuit to take induced current from the loop without any changes. We won't take current as it is, we don't want to change it. Now, question 9. Question 9, it was part A, B was okay, as more progressing was worse, worse and worse. First, people forgot about what is series and parallel connection. In series connection, what is the same in series connection? When we have, in series connection, current constant, voltages is added, V1 plus V2, when we have few, let's say, cells connected in series. This is the series connection of the cells. Total voltage, we add voltages, current is the same. Parallel connection is this, when we connect like this. This is a parallel connection of the cells. Those are cells. In parallel, we have voltage constant, current is added. Plus I2, plus da 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 da, plus. So we have, in series, we need to, we have 24 panels, each produce 25 volts, so total will be 24 times 25, 600 volts. And current same, still stay 20 amps. For parallel, we will have voltage same, 25 volts. The current we multiply by 24, 480 amps. Next was even, I think, even worse, that determine, but it determines who is correct regarding the type of circuit they choose. Joe, who suggests a series circuit, or Phoenix, who suggests parallel circuit. What are the power loss in the connecting wires? How we calculate power loss? I squared R. So the higher the current, the more will be power loss. So which connection will have less power loss? Series will have less power loss because current in series. And if we can calculate for series connection, we will get power loss 20 squared times 1 equal 400 watts. For parallel, we will have the current 480 amps squared times 1. We get loss will be much more than power produced. We will lose all power in the, if we connect them all in parallel, because current will be much higher. In the connecting wires, we will lose all generated power. So parallel connection, series connection has less power losses because of the smaller current. Okay, next question where there were problems. Question 15. Actually, up to question 15, I was quite happy with the, probably because light was the last topic that we covered, so most of the people did decently. But question 15 was not good. So question, especially 15A. Yeah, if you want to go over question, yeah, we'll go over question 14 because question 14. So, question 14A. Explain how the hydrogen absorption spectrum is produced. And I will suggest to put this on your cheat sheet. You don't need to, you can write what I will say, or you can, if you will be unable to write it, quickly you can write, as I'm saying, I've uploaded on my website the detailed solution. So explain how the hydrogen absorption spectrum is produced. When continuous light spectrum is passing through the hydrogen gas, only wavelengths corresponding to the difference between energy levels are absorbed. So will be missing from the spectrum. When continuous light spectrum passing through the hydrogen gas, only wavelengths corresponding to the difference between energy levels are absorbed. Explain how the hydrogen emission spectrum is produced. When electrons are excited to the higher energy levels, they then drop to lower energy levels, emitting light with a wavelength corresponding to the difference between energy levels, so discrete spectrum. Yes?
When do you have to specify that electrons behave as waves and talk about discrete energy levels in general?
When it says about when question asks about why we have discrete energy levels. When it says about and again, you need to look how many marks allocated. If it's 2 marks, it probably will be too much to talk about the standing waves form, so that's what's required. If it will be 4 marks, yes, I will add that only energy levels, the electrons have wave properties with the de Broglie wavelengths, and only the energy levels can exist where standing wave can form, corresponding to the whole number of length speed, and then say that the photons with energies equal different, that's important, don't forget different, not energy equal energy level, but difference between energy levels. But in this case, 2 marks, it will be too much, 2 marks. Question 15. And then we come into not understanding what the plus minus uncertainty means. So when we say that it was given that the mass of the washers is 30.0 plus minus 0.1 gram. What does this notation mean? That means that we know that mass of the washer is between 29.9 to 30.1. That's what exactly that notation means. When we have 30 plus minus 0.1 gram, that means, what the meaning of that? That we can state that the mass of the washer is between 29.9 to 30.1 gram. Make sense? Now, B. Why the washers will be rotating around? What creates the tension? What's pulling the string down?
Gravity.
Acting on what? On the washers. Washers. Gravity pull washers down, and they pull the string, which creates the tension which rotates the rubber stopper. So it's a gravitational force on washers, not on the rubber stopper, it's on the washers. Gravitational force on the washers, it pulls down washers, and that creates the tension in the string, which in turn rotates the stopper. Make sense? Next one, derive the formula relating mass of the washer stopper frequency. We have that the only one force acting on the stopper is tension. But the tension equal created by the capital M mass of the washers. And because it's motion in the circle, this will be equal to, so we have mg equal mv squared over capital R on R. It will be centripetal force. Tension pull that made the stoppers move in a circle, and tension equal mg. You see capital M mass of the washers, lowercase m is the mass of the stopper. Yes?
What, like, I know you explained it before, why does tension equal mg?
Because what creates the tension?
But isn't it like at an, isn't it like at an angle? Yeah.
Like, how can a force going this way have anything to do with the force going this way? Like, if it's in a circle, then the net.
No, but we have that string going like this. We have the stopper here, and we have washers here. They create the tension, and it's the one string, so tension here, equal tension here. Of course, taken strictly, this will not be horizontal. It will have a little bit of the angle, because we have some gravitational force acting on this, so some part of the tension here. So properly it should look.
How do the washers do anything for the entire experiment?
Why it will be rotating?
But you're the person
No.
spinning it. Isn't the person spinning it?
No.
There's a hand on the thing.
It's holding. It's rotate because washers pull in. You just start rotation, and then washers pull the string. The gravity pull washers pull the string, and string makes it rotate. Because so we have this tension will have its vertical component will need to compensate the gravitational force on the stopper. But we disregard that. We consider that it's act only horizontal. We always make a model, we simplify any real situation. So we consider that this is only one force acting on the stopper is a tension, which equals mg. And then to connect with the frequency, you know, V equal 2 pi r. Circumference divided by the period of 2 pi r f. Substituting there, we will get what's required formula, mg equal 4 pi squared, 4 pi squared r m f squared. Make sense?
Yeah.
We have 2 minutes left. So, double I. Double I believe that, because VCAA doesn't provide like their answers, so what I believe should be the answer, that why the X intersection is not, is about 0.15. There are, I will see two explanations. One explanation is that the washer, there is if you look on the diagram, you see washer support. Washer support might have some mass, which creates some tension, even if there is no washers. That's I see one explanation. Second explanation, I see that they did not include uncertainties, so their line of the best on the graph, so their line of the best fit might be not exactly correct. So line should go through the origin. I see these two explanations.
Wait, do you have to get both or just like one of those?
Well, I think one will be, but it's 4 marks. Probably I would put both, with either one or another. Again, VCAA did not give, I don't know what the author of the exam means.
Yeah.
And the very last one. I believe that it is correct that they say that Ishwa suggests that number of washers has been incorrectly counted. Magnus suggests that the frequency might have been measured incorrectly. From one hand, it's easier to count washers than measure frequency, but they repeated experiment. They were repeating experiment. So
How am I going to know how to quantify?
So if they made mistake in one measurement of the period, they probably will not repeat that mistakes 2 more times.
They also did 20-year count.
Huh?
Didn't they technically count the washes again as well?
No, but they did not recount. They count once.
Surely they know how to count to 5.
Okay, I'm pretty sure, like,
that's a given.
what I'm pretty sure VK means, the answer about the frequency because the experiment was repeated. Okay, like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hezbollah, Hamas, etc. Support Ukraine and Israel.